This is a tutorial video to show you how to use final element software Ansys Workbench to carry out simulations for biomedical engineering cases. Once you start the software Ansys, you will see a screen like this. In the middle of the working area, you can see this is a getting started. These are the instructions you probably like to read if you want to actually run the tutorial provided by Ansys. But in our case, because we want to actually learn this quickly, if you follow this case, it takes you hours to finish. We don't have that much time, so we actually have a simple version of the tutorial teach you how to do the simulations using Ansys. So which closest one, unless you have your spare time, you can go through this one. If you like, you're encouraged to do so. Right, once we click this off, then we come to this area. These areas, there are two parts. One is the analysis system. It tells you what kind of work it can be done, what sort of simulation can be done, like electrical, like flows, like the model is just vibrations, and there are also some typical mechanical case, which is the static structure. There are thermal cases, right? And the bottom part, these are the component systems you use to carry out the analysis. Right. Also, it allows you to use one of these components. If you, for example, choose a structure, you are going to use the some of these components, like geometry, like the mesh. You mesh the model, right? Divide the model into small parts. There's also one here is called mechanical APDL. This is the what we call classical Ansys simulation. This is the core part, kernel part of this of the system. The workbench is run based on this one, but it's be programmed more user-friendly. Okay, so these are the things offered by Ansys. For us, we only need to use this one. We only can spend some time on this one and learn how to use this to carry out the simulations. In the future, if you have opportunities to do other simulations, you can actually try to explore yourself. More or less, they are similar as we do for the classical structure. So to start with this classical structure, static structure, we just click on that one and drag this one to this box. Then you will see a list of tasks appears in this window. This is called a project schematic. In this project, what we need to do is we need to actually figure out or assign material properties for the structure we're going to simulate. We're also going to actually either import it or create a geometry, like the shape of the thing you're going to simulate. Then we're going to do the model including mesh, assign the boundary condition, etc. And we do the setup, apply the force, etc. Then we do the solution. The last one, we're going to view the results. Okay, so start with the engineering data, which is the material property you want to assign to your case. So we double click it. You'll see there will be 4 new areas appears in this working area. One is outline of the material properties, and the other one is the properties of the data. Here we have structural steel. So these are the data, mechanical data, physical data of the structural steel. We have also here a chart for the properties like density, at what temperature, and the density, etc. If you want to actually add more materials, right, what you can do is you can use this engineering data source to add more materials. Just click on this one. Then you will see we have one more window pop up. It's called engineering data source. We are talking about general engineering data source. Okay, for example, we want to actually add titanium into this material table. Just click on this one. You can see here we have a titanium, we have other like standard steel, we have other general material properties here, or materials here. If we click on this titanium alloy, you can see the properties of titanium alloy appears in this window. If we click on this plus sign, right, that property now has been added to the material property here. So we can close this window. Then you will see this is added to the system. By default, we have a structural steel. You can delete this one, you can leave this one. At certain point, we need to choose which material can we use as the material of, for example, the implant we're going to simulate. Right. This is just for the first step. For next step, we're going to do that in the next video.